Hello and welcome to the very first video of Interesting Science. My name is Alex, and today I'll be showing you a simple experiment that you can do at home. Then I'm going to explain the science behind what's happening. So, let's get started. First thing you need to do is grab our supplies. You're going to need some salt, some water, a container, a 9-volt battery, and then 2 metal objects. What I have for that is some copper wires, but you can really use anything. Just a few recommendations when you're grabbing this. You might want to use a container that you're not going to eat out of or cook with, because there are some chemicals in this reaction that you don't want to get those contaminated with. And also, if you have distilled water, it's nice to use that because there won't be as many impurities in that. But otherwise, let's get into it. So the experiment I'm going to show you is taking some salt water and seeing what happens when you run electricity through it. So the first thing you need to do is make the salt water, which is pretty simple. You're going to take your container and fill it with however much water you have. I have a beaker and I filled it with about 125 milliliters of water. And then to add in the salt, as a rule of thumb, I would say add about 1/10 the amount of salt that you have water. So I have 125 milliliters of water in here, so I measured at about a little over 10 milliliters or grams of salt. And so I'm going to pour that in there, and then now we just have to mix it up and dissolve all the salt. Okay, so once you get all your salt dissolved, the water should clear up a little bit and you shouldn't be able to see any more salt granules in the water. So now we're going to grab our battery and our 2 metal things, my wires, the wires in my case, and we're going to take them and you're going to hold one of each metal thing. I'm going to say wires from now on because that's what I'm using. One wire to each terminal of the battery, and you want to stick them both in the water. And so once you do that, you should immediately start seeing some bubbles forming on one or both of the wires. One thing to make sure is that the wires don't touch, because that'll just short the battery and the reaction won't happen. So let me bring a closer view of what's happening in this reaction. Okay, so here's a closer view. If I bring these down in the water, you should see that immediately the wire on the left starts bubbling a lot. And another thing that might happen in your solution is it might start to change colors, like a yellowish or brown, and your 2 metal pieces might start to change color. That's completely normal. I'll explain why that happens in a little bit. But yeah, if you look at my copper wire, it started out as that color and now it's starting to turn black. But yeah, so let's see what's actually happening here. So let's go back to the beginning and remember what we started with. We started with just regular old plain water, H2O, 2 hydrogens and 1 oxygen. Then we added the salt, which is sodium chloride, or NaCl. And when we dissolve the salt in the water, the sodium and chloride are going to split. They're going to form 2 different ions. The sodium is going to form a +1 ion, and the chlorine is going to form a -1 ion. The next thing we did is we put the electricity through the whole solution, and that split all the H2O molecules. And that's called electrolysis, where you use electricity to split up the molecules. And that's going to split the H2O molecules into hydrogen, oxygen, and then OH, which is hydroxide. And with all these substances in the water, they're not just going to sit there. They're going to be attracted to either the anode or the cathode, which are the 2 metal pieces you have in the water. And because they're connected to the battery, one of them is positive, one of them is negative. So the anode is the positive terminal, and that's going to attract all the negatively charged particles. So the chlorine and the oxygen are going to be attracted to the anode, or the positive side. And then the cathode, the negative side, is going to attract the hydrogen and sodium. And so the hydroxide is going to be floating around in the solution, and it's going to form 2 different molecules. It's going to form sodium hydroxide when it bonds with the sodium, and it's going to form hypochlorous acid when it bonds with the chlorine. And the hydrogen at the cathode is going to bond to itself and form H2. And that's going to be the gas that's going to be bubbling like crazy, if you notice, on the negative side as soon as you stick it in the water. And then on the positive side, the chlorine that doesn't form hypochlorous acid is going to bond to itself and form chlorine gas. And if you run this reaction long enough, you'll notice that you might begin to smell like pool water, which is chlorine. Sorry, it is chlorine. It'll smell like pool water because of all the chlorine gas coming out of it. And then also at the anode, oxygen is going to bubble out. It's going to bond to itself, and it's going to bubble out. And that was actually the reason that there was some discoloration in the water or on your metal pieces, because the oxygen is going to oxidize whatever metal you have, and that's going to make it brownish or blackish or yellow, or just discolor it. So that's what was happening in the reaction. Okay, now that I've explained everything that's happening in this reaction, I'm going to show you a couple more things you can do with this experiment. So I have a special electrolysis setup here. Most people probably don't have this, but it's going to make what I'm about to show you a little bit easier. So I have the same solution in the water as we started with, so you can see it's bubbling. And that, as I just showed you, is hydrogen gas coming off, and I can show you that because I have a lighter here. And you can see the flame burning, and if I bring it down close to the hydrogen, you can see it starts to burn a little brighter and a little bigger, and that's because the hydrogen gas coming out of solution is starting to burn, and that just feeds the flame a little more. And I also have some test tubes, and I'm going to show you what happens if I trap some of that hydrogen in the test tube and then burn it. So give me. Okay, so I've been letting this reaction go for about 15 minutes or so, and the test tube looks like it's pretty full of gas, so I'm going to pull it out of the water right next to the lighter, and let's see what happens. There we go. Yep, that was the hydrogen gas burning, and it came out of the test tube really quick and made a nice little noise. The last thing I want to show in this reaction is the presence of the sodium hydroxide, because sodium hydroxide is a very strong base. And bases, when they react with litmus paper, which is a pH indicator, they'll turn it blue or green. So if I take this litmus paper and I dip it in the solution, if you can see, it turns it a bluish green color, which shows you that there is a base, which in this case is the sodium hydroxide. Now the reason it's not as clear as it could be is because of the hypochlorous acid, which also forms, and they tend to neutralize each other out. So I don't have any pH paper that's sensitive enough to detect the hypochlorous acid, but since sodium hydroxide is such a strong base, I can see a little bit of it. Yep, but that's my video, electrolysis of salt water. Hope you liked it.